Okay, this is a great demonstration of Newton's second law, which states that an object at rest will remain at rest forever unless that... This is a great demonstration of Newton's second law, which states that the acceleration of an object is equal to the net force on the object divided by its mass. So what I have here is a place setting. And what I'm going to do is I'm going to remove the tablecloth from out underneath the place setting in such a way that the force of friction acting on the place setting doesn't get a chance to act for long enough of a time. Therefore, you'll see very little movement. Now, it turns out that friction has an unusual property. It's independent of the relative speed between the two surfaces in contact, that is the kinetic or sliding friction. So I'm going to pull it really fast, and because the time interval is so short, the place setting doesn't have that much time to accelerate due to the net force of friction acting on the place setting. So here we go. Oh, and by the way, I use this glass here because this was used for the Parkland Junior Senior Prom of 1996, and the saying that year was "in the still of the night." So I thought that was very appropriate. I used to use one from the Junior Senior Prom that said "swept away," but that broke. Okay, so what I'm going to do is pull very quickly, and I'm going to make sure that I'm also going to pull down at the same time. You don't want to pull up where the place setting is going to flip over. Okay, so on the count of 3, 1, 2, oh, and also you don't want to seam along this side of the tablecloth because that could trip the place setting. You also don't want to use a tablecloth that's too stretchy. Okay, so on the count of 3. 1, 2, 3. Woo!